Okay, so using the exponential model, an exponential curve, you've either got a growth curve or a decay curve. So what we can do is fit a growth curve to the first part where our rate is increasing. So that's going to go up to either 35 or 42, depending on exactly how it looks. So first off, if we know that an exponential model is going to be in the form y equals a e to the power of kx, then what we can do to turn our exponential model into a linear model is linear regression. So if we ln both sides, we end up with ln y equals ln a e to the kx. Then we are going to have to separate, so we can go ln a and separate that from ln e to the kx. So ln and e cancel, so we end up with ln y equals ln a plus k to the x. So if we plot this on a graph, on our y-axis, we would plot ln y. On our x-axis, we would just plot x. And then we'll have a straight line such that the intercept is ln a, and your gradient is going to be k. So that's basically having a y equals mx and a plus c equation. So if you work out on Excel or somewhere the value of x, which we've already got, and then ln y, you end up with values that look an awful lot like this. And we've got the debate as to whether we go up to 35 or up to 42 as to our straight line. So if you put this into autograph, then what we end up with is a graph that looks like this. We've got x on this axis, and we have ln y on this axis. And so if we look, what we end up with is basically a straight line that runs in this first section. And although the 42 is pretty damn close, it's not quite on our straight line. So we've got this, and we can call it true definitely up to 35, possibly up to 42. So in exactly the same way as we did when we were working out our linear equation, we're going to find 2 points. So it goes straight through the first one and straight through the middle of the fourth one. So we've got, from an exact point of view, we've got this first one that is going to be at the point 0, 3.97, and then this one is going to be at 21 and 5.20. So, and exactly the same as we did in the first bit, we are going to calculate the gradient. So we've got our gradient happens to be k, so k is going to equal y2, which is 5.2, minus y1, which is 3.97, divided by x2, which is 21, minus 0. And that gives us our gradient, and that gives us k. So, so we've got our equation of 5.20 take 3.97, and that's over 21 take 0. Obviously we don't need to do the take 0, but it's a kind of a completeness thing. So we end up with a gradient which is at 0.0586 to 3 significant figures. And we know what our intercept is. Our intercept is ln A. So our intercept is going to be ln A, and that equals 3.97. So if we were going to find out what A was, we could either do E of 3.97, or we could remember that it was just 53, because that's what we worked it out as. So we can rewrite our original model using our new information. So we've got y equals 53, which is effectively our start value, E, K, which is 0.0586, X, and that is valid from X is less than or equal to, if we go for 35 for safety, because it looks like it's starting to decrease by the time we get to 42. So you can then put this model into autograph, cut it down so it only goes up to the 35, and then use that for the percentage error as well.